In this video, I'm going to show you a shortcut to vector subtraction. But first, let's review vector addition. Let's say we have been asked to draw F net, and we're given two individual forces, F1 and F2. We know that F net is the sum of the individual forces. So in this case, just F1 and F2 added together will give us F net. Okay, then our task is easy. We know how to draw F net. We just add these F1 and F2 tip to tail like we learned. So we draw F1, and then we connect F2, and we do it so that the tip of F1 connects with the tail of F2. Then we draw the resultant, which starts at the very beginning and goes to the very end. And in this case, the resultant, which is 1 plus 2, gives us F net. Vector subtraction is, it can be performed in the same way. I'm going to show you a shortcut that will seem a little weird at first, but watch the other examples in this video and it will soon be very intuitive. Okay. Let's say we have V1 and V2 that are shown, or VI and V final. So here's some initial velocity, and here's some final velocity. And the question says, find delta V, or draw delta V. Really, we would be drawing. Okay then, how do we draw delta V? Well, and my work I will show in yellow. We know that delta V is the final minus the initial. The final and initial velocities are both vectors. Velocity is a vector. Therefore, the difference between them is also a vector. Okay then, how do I find delta V? I simply take VF and I subtract away VI. Here's the shortcut for performing that subtraction. Step 1, you draw the two vectors tail to tail. Gasp. So strange. We've never done this before. Different. Then you start at this vector and you end at this vector. In other words, you draw a new line, a new vector, starting at VI and ending at VF. And that is the difference. So this is delta V. Why does this work? Let me explain this to you. Call the first equation here equation 1. It's easy enough to see that if you add VI to both sides, then the VI will come over as positive, and the new equation would be VI plus delta V equals VF. Consider that equation. It says if you have some initial velocity and you add a change to it, you'll get the final velocity. That's pretty obvious, right? If you start with something and you add some change, then you'll get the final ending velocity. So think about this problem again. I'm going to solve it again. VI and VF, I said you connect tail to tail. When I draw delta V, when I draw in delta V with white, what I'm doing is I'm completing the vector addition. I have to draw delta V so that it connects tip to tail with VI. So I could draw delta V like this, except whoops, that fails to create V final as the resultant. So this is wrong. Let's see. So that's a wrong delta V. I could try to draw delta V over here, and I have successfully done tip to tail. That's a vector addition of these two. But I haven't drawn delta V in a way that VF is the resultant. See how VF is the resultant of the two? It's the sum of the two. So this is wrong and this is wrong. I can't erase right now, so I'm just going to cross them out. How would I draw delta v so that it completes this vector addition with vi? I have to draw it like this. Now I have successfully created the addition of vi with delta. Vi and delta, they are added tip to tail the way we know. And I've done it in such a way that vf is the resultant of the two. Vf is the resultant. It connects from the beginning to the end. So that's how you think about this vector subtraction trick. I'm going to show you very quickly 2 other examples just to help make this concept intuitive. Let's say we're shown 2 vectors, initial momentum and final momentum. And the question says draw delta p. This is a vector subtraction. Here's why. You know delta p is final minus initial. So what the question is really asking us to do is it's asking us to take the final vector and subtract from it this vector. We will use the new shortcut. The shortcut says, step 1, connect the 2 vectors tail to tail. This is the final, and that's the initial. Then it says, consider the vector addition. Instead of looking at equation 1, look at equation 2. Write down the vector addition. You would write it by adding pi to both sides. Oops, I forgot my vector signs. Pi plus delta p equals final momentum. And my second equation here shows me that I need to add pi with delta p. They have to be added together. So the tip of pi must connect with the tail of delta p. And I have to draw delta p so that pf is the resultant and starts from the beginning to the end. Goes from the beginning to the end. So here it is. I do tip to tail, connecting delta p with pi. And there, now I've successfully drawn the vector addition of this plus this, and I drew it such that pf is in fact the resultant, the sum of these 2 individual vectors, pi with delta p. Okay, the last example, I won't use initial, final, or change. I'm just going to use random vectors, a equals b minus c. The question will have shown us b. Let me draw b a little differently. B is like this, and c is down like that. And the question says, draw a. In other words, it's asking us to draw this vector minus that vector. Step 1 in performing our subtraction, step 1 of the shortcut, is draw the 2 vectors tail to tail. So I've now put b and c tail to tail. Then consider what the addition is. Take the subtraction and rewrite it as a vector addition. So I would rewrite it by adding c to both sides, and that tells me that c plus a equals b. Aha! B is the resultant. B has to connect from the very beginning to the very end. And I must now draw A so that it is added tip to tail with C. Easy enough. C, the tip is right here, so that's where the tail of A goes. And I have to draw so that A successfully completes this addition. I look and I say, yes, C plus A does give me B as the resultant. C plus A is B. So step 1 in this method, step 1 is draw the 2 vectors being subtracted tail to tail. Step 2, write not the subtraction, but write down the vector addition. Then step 3 is draw the missing vector to complete the addition. And that's how you solve these problems. So you are going to have some practice. Refer to the video if you need help, or send me an email.